You're terrible.
Never said I was very funny. Okay. Now, as of right now, you guys. As of right now, you guys have only been dealing with numbers that exist, numbers that you can count, numbers that you can work with, rational, irrational, things, whatever. What's going to happen here is we're going to start talking about imaginary numbers. And what I want you guys to think of is the following. What is the square root of 4? 2 or negative 2. And this goes back to the idea of what are two numbers that are exactly the same that you multiply together to get the number underneath the radical. Well, what happens now is you get this imaginary number. Because if you think about what are two numbers that you can multiply together then to get that have to be the exact same number to get negative 4. You can't do it. You can't do it. But those aren't the same numbers. They're cousins, yes. No. What happens here is you have to split this out into two separate values. Whenever you have a negative radical, you break it into the following. Square root of negative 1 times the square root of 4. And the square root of negative 1 is I, imaginary. So your answer here becomes 2I. But what I want you guys to take from today, the square root of negative 1 is I. They use a cursive lowercase I for this. That's why you'll see that I have a little tail on that. And the other part of this is I want you to know that I squared equals negative 1. Oh. Those are the two big parts of it. Yeah.
Do you mind if we just do a regular I?
Just don't make it capital. Two things to go for today. Square root of negative 1 equals I, and I squared is negative 1. So when you go to simplify radicals now, when you go to simplify a radical, for example, the square root of, 20, negative 20. If I just want to simplify the square root of negative 20, I'm breaking it into two parts again. I take out the negative 1, and then I simplify the 20 like I would normally. Yeah, I'll show you how you would write that. So we have negative 1, and then we have square root of 4 and the square root of 5. So you have an I, a 2, and a root 5. The sequence that you place the I value to keep up with that, that mathematical etiquette, if you will, is you always go numbers first, then the imaginary, and then the radical. So you'd say 2I root I. Okay? That's how it's normally presented. Okay?
Wait. We have to write in cursive too.
I don't care.
Okay.
Yeah. Pretty much. Pretty much. So in essence, it doesn't change anything except the following. It doubles the amount of problems you can do now. Yesterday, you guys solved all those equations with, I mean, it really does. You solved all those problems yesterday where you equal some square root equal a positive value. Well, now you're going to be able to solve stuff that has square roots that equal negative. So let me see where I'm at here. Like number 5 here. 2x squared plus 3 equals negative 13. It's going to allow you to do the exact same work that you did yesterday, solving those 2 3-step equations with radicals. But just now your answer, your solution, instead of taking a radical of the square root of 16, it can be taking the square root of negative 16 first. Okay? So what do you do first? Subtract 3. So when I subtract 3, we have 2x squared is negative 16. Divided by 2, very good. So I have x squared equals negative 8. Real fast now. Yes, sir?
Would you put a plus minus?
Very good. Notice I'm taking the square root over an equal sign. Whenever you take a square root over an equal sign, you just throw a plus minus in. And what was the square root of 8? So it would be the square root of negative 8. So here you have x would equal plus or minus 2I root 2. It's that straightforward as to what you guys were doing yesterday. Okay?
Where's the catch? That's what I want to know.
Good question.
Okay.
What's the catch here, Mr. Murphy?
What's the catch?
Yeah.
There has to be.
You're going to have to do.
Do you know what the catch is? I beat AJ and he's smarter than me.
What's the problem? I forgot the one. It's not on this one.
Oh, here's the catch.
No, we're just starting,
That's
man.
my life.
Exactly, that's what I'm scared of.
Plot twist.
Plot twist, not yet. Just wait.
Plot twist.
Just wait.
Climax.
Said by the music.
Oh no, it's scary.
I thought it was
All right.
This isn't scary.
Okay, I just want to walk you through an extra one of these before we get into the little bit weird.
Wait, is it normal?
What is what normal? Everything's normal here.
Yeah.
What do you think?
We divide by negative.
Oh wait, no, I did this one.
You gotta divide by the -6, guys.
Are you going to add 6?
Remember, when you're working in solving for x, you're working with your order of operations in reverse. So you have to divide out by the -6. So we have x plus 5 quantity squared equals -20. And I think we just simplified the square root of -20, didn't we?
Yep.
Do you remember what it was?
5, 2,
2i,
5. So when it's negative, it would be plus or minus 2i. And now you get x plus 5 equals that. Where do I put that 5 now? How do I move that 5? Subtract it. Do I put it in front of the plus minus or behind it?
Front of it.
Front. It's cleaner. It's cleaner. Throw it in front. Yep. There's imaginary numbers show up a lot more in like electronic stuff with resistance and things like that. They use some of it in there. In our level, it's more of an introduction to how you solve stuff with an imaginary number, as opposed to like when you guys get to pre-calc, you'll do some more modeling of how it actually occurs in real life and things like that. The process of working with these is not difficult. There's just a couple of rules you have to remember. Basically, these two. Okay? Now, let me show you what else we're going to do with this. Not only working with this.
Those aren't friendly numbers.
They look like
Okay. What I want you guys to do.
I want you to calibrate this cardboard and active whiteboard.
Something's wrong with it. It's not wrong. There's nothing wrong with it. Make sure you're not making a mess. Now, what this is saying here is we're actually adding together coordinates on the imaginary plane.
Oh my god.
Is this why it is up
Let me explain something to you real quick. Let me explain something to you. I am right now at this moment graphing an imaginary number.
Wow.
No, it's like the x minus little
Okay.
x plus.
It is stuff that you can do. It is something that we're not going to bother with. We're not going to plot imaginary graphing here. Now, one thing I want you to do, though, is what would you do if this was 4 minus x plus 3 plus 2x? What would you do?
You would combine like terms.
What do you think you're going to do with the I value?
Like terms.
It's the same stinking thing.
Oh,
Okay? Now, the parentheses are around each of those two individual terms because, like I said, those are coordinates in an imaginary plane. When you go to work with them via addition, it's nothing more than just adding them together. 4 plus 3, negative I plus 2i.
That's it.
Wow.
It's minus I. That's it.
Oh, okay.
Okay?
That's it. Because I'm thinking negative I would be a positive, wouldn't it? Because it's the inverse of all this.
Just bear with me for a second. Well, I'll show you how that works here in a second. Now, the other part of this where it gets to be a little bit weird is how this is written via subtraction. If you look at it, you have 7 minus 5i minus the quantity 1 minus 5i.
That one thing.
That one thing, what is that one thing called?
Put in,
Anybody but Clay, because it's driving him nuts not be able to answer this right now.
points.
What do you got, Jessica?
Don't you like multiply out the subtraction something?
Correct. That is called
Distribute.
distributed. Now, sorry Clay, I just had to do it because I
I
know
want to
it.
get points, man.
It's okay.
You don't get
Beggars
points.
can't be choosers.
It's all about the
Zero.
points.
points are gone.
What I want you guys to see here,
Your points are gone.
what I want you guys to see here is when you are subtracting out these terms, they're throwing them in parentheses to force you to distribute the -1 to both terms. That's where people usually mess up. When you see a subtraction, rewrite it 7 minus 5i minus 1 plus 5i. I distributed the -1 to the two terms within the parentheses. Is that okay? Now what do I do? What do you get? 6.
So you can get rid of it.
Yes, you can.
The more you know.
Is there a negative in front of this? Because would you have, if you had something like this? Did you distribute the -2 to the one on the left? No, it's the same. You're using the same properties. Okay. It just looks weird because instead of an X, it's not. Okay.
Wait, we're not doing that one?
Do this one. All right. Now, ladies and gentlemen, I won't have to say this twice. The 6 is part of the problem.
That makes
So it is 6 minus the quantity -2 plus 9i plus the quantity -8 plus 4i.
That would I was distributing the negative not the 6.
If it was a -6, the 6 would be right next to the parentheses. Okay. Take a second and try that.
Did you get -5?
We'll do it Tuesday, next Tuesday.
I got -5.
All right, at this point, hopefully, when you guys see this, the negative symbol there, take a second, distribute it out, and just rewrite. So you get 6 plus 2 minus 9i plus, minus 8 plus 4i. Is that okay?
Yeah.
All right, what's 6 plus 2?
8.
Minus 8.
0.
What's -9
-5.
plus 4?
-5.
Bye-bye. Lincoln.
You're done.
Ivy Lincoln.
But wait! Lincoln's gotta go.
Why does that negative distribute it after the
At this point here, you've got, all you're doing is if you block this stuff out, you've got -1 times this, -1 times that, and that's just it, because it's just in front of that grouping. Here, there's a 1 here, and it's what I was worried about. If there was a 2 here, I'd distribute out the 2 to both. All right, so let's get funky with it.
Oh, let's get funky. Yeah, dude.
Let's get Now we have I squared.
What is it telling you to do now?
I'm gonna cry.
Where I?
We have I squared. at Mr. Murphy. You creep me out.
At this point, you are now showing 5i times the quantity, negative 2 plus I. What are you going to do with the 5i outside?
Distributed.
Distribute in. Okay? So I get negative 10i plus 5i squared. We okay with that?
Yeah.
What is I squared equal to? 1. So what is 5 times negative 1?
Oh, negative.
So negative 10 minus 5.
So you get negative 10i
That was too bad.
minus 5. Now, I've told you guys in the past that usually numbers come up front. To be honest with you, if you left it at negative 10i minus 5, it's fine. If you want to rewrite it as negative 5 minus 10i, means the same thing. Okay? The trick here is to remember that whenever you have an I squared, you can simplify that to equal a negative 1. Recombine your like terms. Okay?
So that's the answer.
What is it in even power? So what would it be? Negative 1 still.
Yeah, it could be 1 to the 10th power. And then
Mine. Then you'll have I.
either I or negative I.
You'll have the other I to that. We'll get to it. We're not there yet.
So that's the answer is negative 10.
All right.
Are we doing that today?
No.
Oh, we're doing that one.
Are you like making problems?
Do we have to spell that?
Foil. Very good.
Oh.
Do I get points?
No.
Kidding right now.
Stop begging. Stop asking for it. I'm going to take them away.
My lips are sealed.
At this point here, you're multiplying two terms together, which means you have to FOIL. Good old Billy Binomial shows up to say hello.
Billy needs a job.
That guy's my homie.
So, as you go through this, again, you're going to distribute, combine like terms, and then simplify if you can. Sometimes you can, sometimes you can't. So if I distribute this out, I get negative 7 plus 14i plus 4i minus 8i squared. Are you okay with that?
Yeah.
What's 14 plus 4?
18.
So we have negative 7 plus 18i minus 8 times negative 1. Granted, at this point in time, I'm taking a little bit longer to go through the first few of these, just to kind of oversimplify the process here. What's negative 8 times negative 1?
8.
What's 8 plus negative 7?
1.
So you wind up with 1 plus 18.
This is easy.
It's a lot easier than you first probably were going. Oh, this is going to be awful.
I'm a good guy.
I's not bad.
I is not bad.
I
I is good.
I is. Wait, so I is like
and I know.
plus and minus.
I is good.
Like a positive and negative one at the same time.
I have a gang, and I really binomial right now.
Murphy, do we have to have an imaginary test?
Have your imaginary friend take it,
Yeah, sure.
but I'll give you a real grade.
Hey, this is the difference of squares. I shouldn't have yelled that out to that.
You're right. It's
Sorry,
fine.
folks.
It's okay.
I really am.
Now, I'm going to FOIL this out. I'm going to walk through why this happens. When you FOIL this out, you get 36 minus 18i plus 18i minus 9i squared. Fairly straightforward. Does everybody agree with me on that?
Yes.
What happens to your middle terms? They drop out. They go away. Negative 9 times I squared gets you what? 9. Good. So what's 9 plus 36?
45.
So my answer here is 45. Notice
So simple.
Notice what happened. This is the difference of squares. Your terms are the exact same, except the signs are opposite one another. Remember, if you had x plus 2, x minus 2, you get x squared minus 4. If you had x plus 5, x minus 5, you had x squared minus 25. It was the difference of squares. It works the same way with imaginary. But what this is called, and this is another new little vocabulary trick that we use, is when you have the same values with opposite signs, they're called conjugates of one another. A conjugate. Okay? They're conjugates. Notice what happens when you multiply conjugates together when you have an imaginary. You multiply two imaginary conjugates, you get a real value. See how the imaginary went away?
Yeah.
Well, guess where you're going to use that?
Real life.
When I,
No one uses that.
So, I is the,
when I is in the denominator.
I'm so confused.
No, all we're doing is, why do we need to know what the conjugate means?
So you can multiply it by its conjugate.
Let's say you have this fraction and we're going to simplify it. 3 divided by 2 minus I. Just like we did not like to have radicals in the denominator, we don't like to have imaginaries in the denominator. So we're going to multiply it by its conjugate. Because if you multiply the denominator by the conjugate, the i's go away.
So
Remember when we did this one here?
What if it's?
What happens here is, if you go back and look at it, do you agree that it was, when I FOIL this out, you get 36 minus 18i plus 18i minus 9i squared? You okay with that?
yeah.
All right. The two middle terms drop out. You okay with that? What's I squared? What's negative 9 times negative 1? So you have 36 times 9, which got you 45. Multiplying by a conjugate with an imaginary term gets rid of the imaginary term.
So you write the definition of the kind, you get,
And there is no full-on definition. All it is same numbers, different signs.
Is that
The opposite.
Is that
So if you have a
because
negative sign, you put a positive.
I'm getting that right now.
is that because I is always one of the two conjugate ones?
Yeah.
you spell conjugate like,
J, conjugate. I don't know.
gap.
C-O-N-J-U-G, except no R.
yeah.
Good spell conjugate. Page.
C-O-N-J-U-R. I had to think of that.
Conjugate.
All right. At this point here, I'm going to worry about getting rid of the imaginary number in the denominator, which means I'm going to multiply by its conjugate.
Then you got four.
Yes.
The conjugate of 2 minus I is
2 plus I.
Then you got the four.
Now, if I multiply the bottom by 2 plus I, what do I have to multiply the top by?
The 2 plus I.
Because what am I doing here?
You're doing the thing.
You're
I'm multiplying, I'm rationalizing the denominator by multiplying by a factor of 1.
Whoa.
Yep, and then
Same thing you did with square roots. You multiply by root 2 over root 2, which is 1. Here I multiply by 2 plus I over 2 plus I, which is still 1. FOIL it. On the denominator, you get 4 minus 2i plus 2i minus I squared. I'm just writing it long way out. Okay? Middle terms go away. Do we agree?
yes.
Okay. So now we have 4 minus a negative 1. 5. So my denominator becomes a 5. And I no longer have an imaginary term there. That's all you got to do. Distribute out the numerator, you wind up with 3 times 2 plus 3i, so you get 6 plus 3i, and that's a simplified version.
I still don't get why having like the weird thing on the top of the fraction instead of the bottom.
It's just the rules that have been in place for centuries.
Well, that doesn't help with though.
This is 3 mules times 2.
It's what they call an exact answer. That's just the way that they've always written these things out.
Have it on
Yeah.
top.
Okay. So let's look at another one here before we run out of too much time.
That was great.
Whoa.
All right? Try the other one. Now, in this one, the second one I have up now, you'll notice that when you distribute your numerator, you'll have to refoil and recombine. Okay? But you're still doing the same process. You're just multiplying out. Once you get going, you'll start to see there's some shortcuts. I'm not going to mess with them right off. I'm hoping you guys have started to multiply the top and the bottom by 1 plus 2i.
Yeah. Wait, is it just 39?
Yeah, we have 13i, so it's 5 plus 13i minus 6, I believe.
Yes.
So your final, hopefully you guys got your final answer, negative 1 plus 13i over 5. You guys get that?
Okay.
Now, I'm going to show you what your answers look like in the book. Do you guys agree by this statement, 5 is the common denominator of the 1 and the 13?
Yeah.
I don't know.
What happens in the book is that they write it out a little bit different. They write it as negative 1/5 plus 13i over 5. The reason that they do that is sometimes you can simplify one of those two fractions. Okay? So let's say it was 15i. You could simplify it. Okay? Does that make sense?
Yeah.
That's really the only reason why they do it that way. I am, to be honest with you, perfectly fine if you write it like this, but pay attention if you can simplify one of the two fractions, okay? So just be careful. Yeah?
Can you go up a little bit so I can see the top of it?
That's basically what you're looking at doing tonight, guys. We're going to have a couple of problems of solving the equations, same way you were doing before. A couple of the adding together, subtracting together, a couple of multiplying, a couple of dividing. All right?
I'd like it for 3 and 4.
Good. Tomorrow we'll complete the square.
I like that.
What's that? Oh, it was minus 2i plus 2i. It was minus 2i plus 2i. The 540, yeah. Guys, if you look on the board over to your right, I have it already up on the board in green. It's on 277. I'll put it up here on the board here in 1 second.
I already finished it.
Oh, yeah, because this is times here. I'm multiplying those two all together to get rid of it. Does that make sense? All right. So tonight, do these. It's section, was it 5.4?
77, 21 through 27, 39 through 63, and then write odds and big letters.
Compact.
Yep.
All right? On these things, make sure you check your work. Don't freak out if some of your fractions look a little bit different than what you're getting in the back. It's probably why one of them wasn't simplified through, okay? Next Tuesday.
Get a robot, you didn't write it.
Other questions on this?
Good. Only homework. I put witness.